Hi everybody, this video is going to be about relations and functions. And we're going to start off with some basics, some definitions, some vocab. But this is the first video for chapter 3. So I want to start off by talking about the parts of a coordinate plane. And you've seen this before, but I wanted to make sure that we're all on the same page. So we're going to label a couple things here. We're going to start by labeling the origin. So the origin is right in the middle of your coordinate plane, so it would be this point right here. Okay, this is the origin, and keep in mind this would be the ordered pair 0, 0. Okay, it has an x value of 0, a y value of 0, which brings us to the next thing, which is our x and y axis. So our x-axis goes from left to right. Our y-axis goes up and down. And we also want to label the quadrants here. So in the upper right-hand corner, this is quadrant 1, and then we move counterclockwise, so quadrant 2, quadrant 3, and quadrant 4. So we're going to be doing some graphing today, and you need to know these key parts of the coordinate plane. And you also need to know what an ordered pair is. So an ordered pair is written as x comma y inside of a set of parentheses, and it represents a point on a graph. So each ordered pair, when we graph, has an x value and a y value. So below here we have some points. Okay, we have points A through F, and what we're going to do is we're going to find that point on the coordinate plane. We're going to write down its corresponding ordered pair, and then also identify which quadrant that point lies inside of. So if we look at A, okay, A is right here. Now, when you do this, I want you guys to start at the origin, and I want you to count you have to move left or right, how far you have to move up or down, and that's going to help you find your ordered pair. So if I start at the origin, I have to go left 3, so that means my x value of my ordered pair is going to be negative 3, and then I have to go up 1, 2, 3, 4. So the y value is a positive 4. So moving left makes it a negative x value, going up makes it a positive y value. And if we look back up to what we had up top here, we can see that point A is inside of quadrant 2. All right, so point B, let's erase this, start over. Okay, point B, if I start at the origin, I have to go right 2, so that'll be a positive 2 for x, and then I have to go down 1, 2, 3, so that would be a negative y value since I had to move down, and it's located inside of quadrant 4. All right, moving on to point C. Now, point C is a little different because point C is lying on the y-axis. It's not technically in a quadrant, so let's just write down y-axis here. And if I start at the origin, I don't have to move left or right at all to get to C. I just have to go up 2. So the ordered pair will be 0 for x and positive 2 for y. For D, I have to go right 3 and up 1, so my ordered pair is 3 comma 1, and it's in quadrant 1. For point E, I have to go left 2, down 1, 2, 3, so it would be negative 2, negative 3, in quadrant 3. And then our last point F is on the x-axis. Now my ordered pair, since I only have to go right 5 and up none, down none, my ordered pair is 5, 0. Okay, so that's how you can identify points, write the ordered pair, and if you can do that, you can probably take an ordered pair and plot it as well. So the last two definitions we have on our front page here is a discrete graph and a continuous graph. So there's two types we're going to look at. A discrete graph is a graph that is made up of unconnected points. It kind of just looks like a scatter plot. You plot your data points, but you're not actually connecting them together. It's just a bunch of points on a coordinate plane, similar to what we saw up here, where we were naming these points and giving their ordered pairs. So that's a discrete graph. A continuous graph is a point where, or it's a graph where the points are connected by a line or a curve. Connected is not a word. Connected by a line or curve. There we go. Okay, so just some basic vocab. Now, the next thing we're going to talk about and kind of tie in with this is a relation. Okay, a relation has a very basic definition. It's just a set of ordered pairs. Remember, we just said an ordered pair is represented as x comma y in parentheses, and it represents a point on a graph or a coordinate plane. Now, within a set of ordered pairs, so this means if it's a set that there's more than one, okay? So if we have a bunch of points, a bunch of ordered pairs, the set of all of the x values of those points would be called the domain, and all of the y values in that set would be called the range. So here's what we're going to do. We're going to look at a set of ordered pairs. So this would be a set of ordered pairs. Notice we have some curly brackets, but I have 1, 2, 3, 4, 5 different ordered pairs represented in this relation. We're going to start by finding the domain. And when we're finding the domain, we're finding all of the x values in this relation. So we have all of these x values here, and we're going to list them out. And I want you to list them, I want you to sort them, arrange them from least to greatest. So we'll do -3, -1, and +3. Now you'll notice we had two -3s, but I only counted it once. I don't need to double count a value for my domain. And we can do the same thing for range. Range is all of the y values. So we have 1, 0, 2, -4, and 5. And again, we'll arrange these from least to greatest. And notice I'm putting my values in a set of curly brackets because I'm showing that it's a set of numbers. So we didn't have any repeating y values. That's why I have all 5 of them here. So what we're going to do now is we're going to represent this relation in a couple different ways. Okay, up here in the red box, I have it just as a set of ordered pairs, just listed out. Okay, but we can very easily take that and represent it as a table. Okay, in a table, each row represents an ordered pair. So if I had the point -3, 1, I'm going to split that up into the left column with the x value and put the y value in the right column. So that represents that ordered pair -3, 1. I can do the same thing with -2, 0, 1, 2, 3, -4, and -3, 5. And if you wanted to order these from least to greatest, that would be fine. Okay, but that's just a different way of basically rearranging and organizing the same information. Another way to do that would be to make something called a mapping diagram. In a mapping diagram, we have our x's, or the domain, in this left bubble, and our range in the right bubble. So let's just copy down our domain values that we have, and our range values. And what we're going to do is, since it's called a mapping diagram, we're going to draw an arrow from the x value to the y value that it's paired up with. So if you look back up into that red box, -3 was paired with a y value of 1. Okay, the x value -2 was paired with 0. 1 was paired with 2. 3 was paired with -4. And -3 was paired with 5. So you'll notice that I have 2 arrows leaving -3 out of the x bubble because -3 was paired with 2 different y values. So we have 2 arrows. So So that's called a mapping diagram. The last way is to plot them on a coordinate plane. So remember, this is our x-axis, our y-axis, and we're going to plot the points. So we have the point negative 3, 1, negative 2, 0, 1, 2, 3, negative 4, and negative 3, 5. And that would be our graph. So everything on this page is just a different way of organizing and representing the same relation. We can have it as a set of ordered pairs. We can represent the domain and range in the curly brackets. We've got a table, mapping diagram, and this would be an example of a discrete graph. We're not connecting the points. So let's expand on this. Okay, this is what a relation is. It's pretty basic. Now, let's add a condition. Let's say I had a relation where each of my x values is paired with exactly one y value. Okay, if that's the case, that relation is what we call a function. Okay, a function is a relation where each x value is paired with only one y value. And here's kind of a quick way to check. If we have a set of ordered pairs, a table, a mapping diagram, we can easily tell if that relation represents a function if none of the x values repeat. So in other words, if we do have x values that repeat, it's not a function. When we get to the graphs, we're going to use something called the vertical line test to determine if it's a function or not. And I'll explain that when we get to the graphs. But we're going to start off with just some ordered pairs, some sets of ordered pairs. Okay, so each of these is a relation. We're trying to determine which of these relations are functions, which is more specific. It has to, we have to make sure that each x value has only one y value that it's paired with. So like we said, we're looking to see, do we have any repeating x values? Well, looking here, I don't have any repeating x values, which we can then say that each x value has exactly one y value it's paired with, so yeah, it's a function. Okay, for number 2, again, we're looking at those x values. Negative 2, 0, 2, 3, 2. Well, let's look here. This point has an x value of 2, and this one also does. So what we have is 2 is being matched up with a negative 4 and a positive 4. Okay, because this x value has multiple y values it's paired with, it's not a function. Number 3, we've got x values of negative 4, negative 3, negative 2, negative 1, and there's another negative 3. So let's look. Negative 3 is being paired up with a y value of negative 1 and 2. So because of that, it's not a function. And for our last one here, we check all of our x values, and we see none of them are repeating. Each x has one y value it's paired with, so yes, it's a function. So that's a pretty quick, it's a pretty easy way to tell if a relation represents a function or not. So let's look at it as a table. I think the tables are even easier. All you have to do is look down your x column and see if you have any repeating x values. We can see our top and bottom entry here both have an x value of 3. They're paired up with different y values. Here we have a y value of 5. Here we have a y value of 3, so this one's not a function. Okay, again, look down your x column. If you see any x's that are repeating, it's not a function, but here we have a different x value every time, so yeah, it's a function. And our last one here, again, we're looking down the column. Do we see any repeating x values? No, so it's a function. All right, I've got another table here, but we'll skip over it. Okay, I want to talk about these mapping diagrams. So with the mapping diagrams, remember that The x's are on the left, the y's are on the right. And to tell if each x has one y value it's paired with, you need to make sure that each x value has only one arrow leaving. So each x value is paired up with exactly one y value. So this would be an example of a function. But if we look at number 10, we have an issue. The issue is that this x value of -1 is getting mapped to a y value of 7 and 0. So because of that, this one isn't a function. Now, graphs. I told you we would come back to that vertical line test, and here's what the vertical line test says. It doesn't matter if you have a discrete graph or if you have a continuous graph. The vertical line test says if you can draw a vertical line through anywhere on your graph, and if it only crosses once each time you draw a vertical line, then it's a function. If at any point you draw a vertical line through your graph and you see that it's intersecting or crossing your graph more than once, then it fails the vertical line test, meaning it's not a function. So here's what we do. We're going to draw vertical lines. And if each time I only pass through one point, we're good. It's a function. The issue is, when I drew this vertical line here, I passed through 2 points at once, meaning it fails the vertical line test and it's not a function. So let's try another. Draw vertical lines. And here, each time, we only pass through 1 point. So this one's yes, it's a function. This one, number 13, we get into this issue again of passing through 2 points. So this one would be no. So that's what it looks like for a discrete graph. For a continuous graph, we're doing the same thing, right? I would recommend drawing multiple vertical lines, because if you see here, with my first pass, I only crossed through 1 point, which is fine, but my next ones, I hit twice again. So this one fails the vertical line test. It's not a function. Okay, for number 15, draw some vertical lines in here. Each time it only crosses once, so it's a function. And then this nice curvy one here, draw our vertical lines in, and each time, again, it's only crossing once. So it passes the vertical line test, meaning it is a function. So that is it for this video. Okay, you've got quite a few definitions. You've got relations, you have functions, and quite a few other things. So feel free to rewind, go back, rewatch, and please ask questions.